Hey there, folks, ladies and gents. This is Mr. Dickin here for some collegiate algebra graphing systems of inequalities. So systems meaning there's more than one, inequalities meaning we're dealing with less thans or less than or equal to's or greater than or equal to's. So when we graph these, we're going to treat the inequality symbol almost as if it were an equal sign. So I'm going to graph this as if it were to say y equals 4x minus 3. But then I have to pay close attention to these inequality symbols here because that will tell me if I'm going to use a solid line versus a dotted line. And it's going to tell me if I'm shading above the graph or if I'm shading below the graph. So first, if I treat this like an equal sign, it's already in slope-intercept form for me, which is great. I've got a y-intercept at -3, and my slope is going to be 4 over 1. So I'm going to go up 4 over 1, up 4 over 1 to get my next point. Now, since it is a plain old greater than symbol, right here is just a plain old greater than symbol. It doesn't have the underline piece there. I'm going to use a dotted line to to connect those. So I'm using a straight edge here. If you guys have like an ID or something, you can use that. Works perfectly fine. All right, then I need to get to shading. Now this is a greater than. Anytime I have a greater than, I'm going to shade above my line. So the way I like to vision this is I just choose any random spot on my line and I drag my pen or pencil above that. You'll notice I'm doing it kind of faintly here. And that's because later on I'm going to look for where they overlap and I'm really going to color that in nice and dark. All right, the next one, I've got -2x plus 3. So my y-intercept here is at +3. My slope is going to be down 2 over 1, down 2 over 1, down 2 over 1. Now, if this was just a straight up solving a system by graphing, normally we'd be looking for that intersection point. But with inequalities, instead of one singular point, in this case it would have been 1, 1, we're looking for an overall region. All right, so I've got my points plotted. This one does have the underline piece, which means I am going to use a solid line to connect. Shibuya. And it's also a greater than, so that means the shading is going to go above. So again, I'll just touch the pen to my line and then kind of drag it upward from there. So now I'm looking for the area on the graph in which both lines would have shading that overlaps, and that region would be this little triangular piece up top. So since we have inequalities, any single point within this shaded region or on the solid line would satisfy both inequalities. If these were both equal signs, however, then I'm looking simply for the point of intersection, which we found to be 1, 1. But they're inequalities, so our solution set should be a shaded region. All right, 2 more examples, and then we're going to cut you loose. All right, next one here. Hey, didn't mean to bump the camera. My bad, folks. All right, first one, I've got y less than 3. Well, anytime it's just a straight up number, that tells me I'm going to have a horizontal line, because I could think of this as 0x plus 3, meaning there's a slope of 0, so a horizontal line there. And it's a less than, strictly less than, so I'm going to use a dashed or dotted line. It's less than, so I'm going to shade underneath. So again, I'll just touch the pencil to my line and then go downward from there. And I'll do it nice and faintly. Next up, I've got -x. Well, that's a -1x plus 1. So my y-intercept here is going to be a +1. And my slope is down 1 over 1, down 1 over 1, down 1 over 1, so on and so on and so on. Or I could go backwards, up 1 and backwards 1. Again, if these were equal signs, I'd just be looking for the point of intersection, which would be right here. But they're not equal signs, they're inequality symbols, so I have to look for the region, the shaded region here. It's got the underlined portion. It has the or equal to aspect of it. So I'm going to go ahead and connect those with a solid line. And since it was a less than or equal to, not a greater than or equal to, I'm going to shade underneath. So again, I'll touch my pen to the graph and go down from each point. And it appears that the region in which both shadings overlap is this whole bottom left section. So this whole region here. Please forgive my first grade level coloring abilities. All right, last and final one. We're going to do number 9. Number 9 is currently written in what's called standard form. Standard form is good for finding x and y intercepts, but for the sake of graphing, we're not going to get clean values, so we're going to throw them both into slope-intercept, y equals mx plus b. So we're going to treat the inequality symbol as if we're an equal sign, and we just have to keep an eye out for negatives. So I can already tell this one is going to give us some trouble. We have to keep an eye out for negatives. If we divide out by a negative, we're going to have to reverse the symbol. All right, so for this first one, I'm going to move the 4x to the other side. So 3y greater than negative 4x minus 6. Then I have to divide everything by that 3. So I'll have y greater than negative 4 over 3 does not simplify, so negative 4/3 x. Negative 6 over 3, that's going to be a 2. So that's my first inequality. Second one, I'll move the x to the other side, so negative 3y less than or equal to negative x minus 9. And now I'm dividing everything by a negative 3. So if I divide by a negative 3, that symbol is going to flip around. So it becomes a greater than or equal to now. So if y is greater than or equal to negative 1 divided by negative 3 is a positive 1/3 x. Because remember, there's technically a 1 there. Negative 9 divided by negative 3 is a positive 3. All right, so first one is going to be shaded above with a dashed line based on that symbol. Second one is going to be shaded above with a solid line. So y-intercept is negative 2 on that first. Slope is down 4 over 3, so that would be like down here. Or I could go backwards. I can go up 4, backwards 3. That's a dashed line shading above. Boom, boom, boom. Ooh, I got a little out of control with the shading there. Second one, we have a y-intercept of positive 3, and the slope is 1/3, so up 1 over 3, up 1 over 3, about there. Backwards, again, if we were looking for just straight up lines, we'd look for that intersection point, but these are inequalities, so we're looking more for a region. That gets a solid line. Shading is also above for that one. So now we look for the region at which, region at which these things overlap, and that appears to be this little triangular spot up top. That's it, that's all. Hopefully you guys have a good grasp on it. If at any point you're confused, please don't hesitate to let me know. And my last piece of advice is just make sure you're being very, 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 very careful with negative signs. That's probably the most common source of mistakes.